Today we are going to be talking about earth science, weathering, and erosions. And you missed my little presentation there where because you were talking. But it was cool. I bet the people that saw it thought it was cool.
It was cool.
Maybe.
It was.
Anyways, what is erosion? Someone show me our sign for erosion. Everyone show me. And what is that? What is erosion? Brooks? Erosion can be big rocks rolling down a hill. Erosion is the process of moving broken rocks, sand, and soil from one place to another. So, actually, did you hear that? Can't hear me if you're clapping, right? So, when we do erosion, it's because we're moving our rocks. So, everyone do that motion. Erosion. Good. Now, what is our motion for weathering? Tori, show me weathering. And why do we do this? What does that mean? Mila? It's something staying together and then it breaks apart. We have our rock, and over time, those rocks break into small pieces. Kind of like glass, shatters, right? Weathering is the process of breaking rocks into smaller pieces. So everyone show me your weathering. You have your rock, and it breaks into smaller pieces. Weathering happens slowly over time and helps change the Earth's surface. Our weathering, move it apart. Earthquakes. Last time we talked about earthquakes. Everyone show me an earthquake. Okay, now come back. What do we know about earthquakes? Do they take a long time to change the earth? Or do they take a short time to change the earth? William?
A short time.
Good, it takes a short time, right? We talked about how earthquakes can happen in minutes, right? Or hours. And how that church that we looked at changed very, very quickly. It didn't take years for that church to change. It took minutes. So today we are going to identify and discuss how water changes rocks, and we're going to explain how weathering and erosion change land over time. Why is this important? Well, this is important because weathering and erosion shape landforms like valleys, mountains, and beaches. It helps form soil for plants, which is important because we need plants to survive, right? And it changes the Earth's surface over time. Everyone get out your science books, turn to page 74 and 75. We don't have earthquakes tonight. I'm hearing a lot of voices. Thank you, Camila, for not using your voice and getting your things out. Kylie, Camila, you make this up. Oh, yes. Okay, we said that before. Sorry about that. Forgot. The page is 74 and 75. If you were listening and had you looked up at the board, you probably would have seen it. Most of you should have your books. If you're someone like Kiara, you'll share with Mary. Okay? Yep, and Max, you are someone that also does not have a book. You will share with Mila. But be respectful. Don't be too close to everybody. Is that something we're saying right now?
What?
Probably not William, right? We're focused on what we're doing. Face forward, both of you guys. Are you facing the road? Should be facing the road. What is the title of this page? Can you ever scoot your desk back where it's supposed to be? And Nora, can you answer my question?
Weathering and erosion.
Weathering and erosion. Look at the unusual rock shapes in the picture. Processes called weathering and erosion carve them. Weathering and erosion change Earth's surface. Weathering can break rocks into smaller pieces. What happens to these pieces of rocks? Wind and water can carry the pieces to new places. The moving of rocks, sand, or soil to a new place is called erosion. Open it back up. This rock formation in England is called Durdle Door. The arch formed when parts of rock were weathered and eroded away. So, when we look at a full picture, we talked about how waves can crash up onto rocks, right? And we looked at that other one where over time the weathering had taken off part of that road, right? And you could kind of see where those waves would come up. Kind of that same thing here. You can see how the waves maybe over time crashed into these rocks and made them form like that. Or how water and waves maybe came through here, or wind was blowing through there and it moved those rocks and those soil, right? Well, when we talk about earthquakes and volcanoes, it takes like hours, maybe minutes even, right? Or even seconds. When we talk about this, did this arch, Durdle Door, happen in seconds, minutes, hours, days, months, or years? What do we think? Camila? Years? Ethan, what do you think?
Same thing as Camilla.
Same thing as Camila? Nora, what do you think?
Minutes.
Minutes? Kiara, what do you think?
Days or weeks.
Days or weeks? Stella, what do you think?
I think it could take years because it has to have a lot of rocks to make the big.
Good. So, if you were someone that was thinking or said years, I think you are right. I agree with you. Erosion and weathering can take years, and not just 1 or 2 years, lots and lots and lots of years, right? It takes a very, very long time for this to happen. So if one wave crashed into it, probably didn't do that in just a second or minutes, right? Even weeks, a couple waves push into those rocks, probably didn't move, but it moved a couple rocks, right? And over the years, those couple rocks broke, and then it ended up being a lot of rocks over time until you had this. And I will have you put away your books. No. Did I say we were done with science? Or did I say put away your books? I wonder what I said. I think most of the class knows what I said. But thank you. So, we are going to learn a little bit more in depth about erosion before we go to recess. So, erosion and weathering change Earth's natural features. Weathering breaks down rocks into smaller pieces. Through erosion, those pieces are carried to new places. Well, we know that erosion happens over time, and it's when rocks move, right? But then we have to think about, how do they move? Does erosion happen if I pick up a rock and just move it? We talked about waves, and waves are made of what? Brooks?
Water.
Water. Is water the only way that erosion and weathering can happen? If you shook your head no, you would be right. Wind erosion exists. So wind erodes lands that are not protected by plants and trees. Wind erosion is greatest in desert areas. Sand blown by windscapes against rocks. Blowing sand wears rocks into new shapes. So I know we've seen pictures of the Grand Canyon before, right? And they said that the Grand Canyon was formed by erosion. So over time, it's kind of a desert-ish area, right? see a lot of dirt, we see some sand, but we don't really see tons of trees. We don't see water like the ocean, right? Talk about our different landforms. It's kind of more like our desert area, right? So you wouldn't see water erosion because there's not that much water, right? You probably wouldn't see ice erosion. You would see wind erosion. Then we talked about water erosion, like with our oceans, in that picture we just looked at. Water is more powerful than wind in causing erosion. Acid and rain makes cracks and holes in rocks. Rain and snow wash broken rocks down hills into rivers. Waves pound and slowly wear away rocks. So, both of these take a long time, right? But because water is more powerful than wind, do you think it takes water a longer time or a slower time to cause erosion? Talk to your partner.
I think it would take a short time, like probably about a couple of hours.
So what do you think? Now that you've talked to your partners, if water's more powerful, does it take longer to erode? Or does it take slower? Rex?
Longer.
Why? Not that you're right or wrong. Just wanted to think. I'll come back to you, okay? Harper, what do you think?
Slower.
Why?
Cause if the ocean's going slow, so
I like the track you were going on. Tori, what did you say? So then would it happen slower if it hits more rocks off and it's more powerful? I like your thought. So I've heard slower a lot. I think that it will go faster. The water would erode something faster because it's more powerful, like you said. And you said that the water crashes into things. And then Harper said that it happens over a long time. And it does happen a long time, right? So water erosion still takes a long time compared to an earthquake, right? It still takes years. But water erosion compared to wind erosion, water erosion is going to be faster. Now, then we think about our ice erosion. Ice causes the strongest erosion. So this happens the quickest. It still takes a long time, but it happens faster than some other types of erosion. Water seeps into rocks and freezes. Ice takes up more room than water. Ice cracks the rocks. Glaciers are giant blocks of ice scraping land as they move. So if you've ever seen a movie and you've seen those giant icebergs, ice is hard or is it soft? William?
hard.
Jasmine, is ice hard or soft?
Hard.
Hard, right? So as it moves, that ice pushes the rocks, right? So we already know that water is going to be a little bit more damaging and going to be faster erosion than wind. But ice is going to be even faster because that ice is hard. Then we think of our soil erosion. Plants and farm crops grow in topsoil. The soil has food that plants need to grow. Wind and rain erode topsoil. People protect land from soil erosion. Do you think soil erosion happens faster or slower than ice erosion? Talk to your partner. And why? Tell me why. Don't just say faster and slower. Tell me why you think that too. So, what did you talk about with your partner? Nora?
I think it takes slower because it takes time to get through the rocks and dirt to go through to make erosion.
If you agree, raise both your hands. Max, you disagree? Tell me why. Said the same thing during math, right? Gotta make sure you're paying attention. Good. Hands down. I would agree with you. Ice erosion is going to be slower than soil erosion. Jasmine said something really good to Stella that I liked. Jasmine, do you want to share with the class? What did you say about soil erosion?
That if we walk in soil, we will walk slow.
Good. So if we walk in soil, if you've ever walked through dirt or even mud, and then you look at the bottom of your shoe, you might have a little bit of dirt, right? So when you go out to recess, if you walk, you might have a little bit of dirt, just the smallest amount of dirt, right? And imagine, if we walk through soil, how long would it take to make something, an indent in that? Take a long time, right? If I just walk over the soil once, is there going to be a big valley?
No.
Probably not, right? It'll take, if I dig, right? But I would have to really dig into it. It'll take a long time. So that soil erosion is going to take a lot longer than our ice erosion. All right, and I will have everyone. Wait, we don't even need coats, actually.
Yeah.
We don't even need coats. We're good. All right, so I will have everyone stand up and line up. Yes. All right, so now that we are back, you're going to finish our list. Okay. So, different types of erosion. Again, we have our water, we have our wind, and we have our ice. Which one is going to be the fastest type of erosion? Chloe, take a couple deep breaths, and then you gotta be with us, right? Take a couple deep breaths. Right, then we gotta move on. Mary. Not sure if I agree with that. William?
Ice.
Ice. Ice is going to be our fastest type of erosion between these three. It still takes a long time, but that ice, because the water is solid, right? That ice is hard. Maureen, how are you supposed to sit? Where are you supposed to be sitting? Face forward. You leave it on the ground. Face forward. Okay, that's what we're doing right now. Good. So our ice is going to be the fastest. Then, what's going to be the next fastest? Harper? Water. Our water erosion is going to be quicker than our wind. So then that leaves our wind for last. Our wind is going to be the slowest between these three. So, now we have types of weathering. So we have fast land changes. Talked about these yesterday. Give me an example. Ethan? What types of things can change the earth very fast? Mary? I agree. Maxwell, I always tell you. So do you have to ask me? Right? I will land changes are earthquakes. Those change the earth very, very fast. Marian, please sit the right way or else you will go back to your desk. Tori, what's another fast one? Volcanoes? I also agree with that. Now, someone give me an example of a slow land change. Angel?
Wind.
Wind? Josiah? Soil? I also agree with that one. And these are types of... Emily? Mila? Erosion. Good. So we have slow land changes, and how long does it take? Jasmine?
Like weeks.
Might take a little bit longer than weeks. That's good though. Mila? Maybe a little longer than just 1 year. Ethan?
Years.
Years! Many, many, many years. So good job, Camila. You said years, or you said a year, but years, right? So many, many years. Good. So Jasmine, how long?
Many years.
Good. Camila? Max? Ian? Chloe? What was that? Many years. Now our fast land changes. If a volcano erupts or an earthquake happens, how long would that take? Brooks?
Years.
If a volcano erupts, is it going to take years for that to change?
No. Days.
Maybe days for that lava to cool down and become rock. What about an earthquake? Ada?
Minutes
Minutes and
and hours.
hours. Earthquakes can change land in minutes and hours. Brooks, can you face the right way though and sit right? Thank you. So, earthquakes can shake buildings and break them like that church we saw, right? And it can cause cracks in the earth within minutes and hours. So, you're going to have enough time. We're going to close out with our learning targets. I can identify and discuss how water changes rocks. I can explain how weathering and erosion change land over time. And again, why is it important to know? Well, weathering and erosion are important because they shape landforms like our valleys, our mountains, and our beaches. They help form soil for plants, and they change the Earth's surface over time. Now, you are going to give me 2 examples of slow land changes. Just went over it together again. Amran, you can go back to the now.
So we're gonna color it.
So, I will.
leave this here so that every time you can see
Oh,
it.
yes, thank you.
But in case I'm not back, I will have it.
So,
I used to